We're going to start with some minerals. And this is an example of a mineral. And you might think it's a rock, and you'd have to go through your rock and mineral keys to try and figure out if it was a pure mineral or a mixture of rocks. But I'm going to jump ahead because I know this is specific one is a mineral. And I'm moving it to try and shine. See how that whole side shines at one like a facet? That's one plane of cleavage. And this one does it too, but not quite as well. So this is what I mean about this is a pretty good plane of cleavage. This one, it's okay. This one, not so much. So we've got a plane of cleavage running this way and a plane of cleavage running this way, and then this is just breaking in this direction. And it's sort of at that angle in that direction and kind of almost 90 degrees in this direction. So that's one of the things that you would test with an igneous rock. Other things you'd test is if it will, how hard it is. Can it scratch glass? So this does not scratch glass. What about a steel knife? It does scratch a steel knife. So it probably will scratch a copper penny then. It's important that you get older pennies. Yeah. Less obvious, but it's definitely scratching the copper penny. So if you look at your Mohs hardness scale, you can get an idea of the hardness based on the things it can scratch. So glass is just over 5, so about 5.5, whereas a knife blade, your typical stainless steel knife blade, is 5. So the fact that it'll scratch a knife but not glass means that it's more than 5, less than 5.5. The luster of it, we say, is shiny where there's a cleavage plane, and kind of opaque and milky where there isn't. It's opaque everywhere, like you can't see through it. So this one, again, shiny. You can see those cleavage planes on each side. So it broke off in those planes. This is perfect cleavage, pretty much, in a cube. It's pretty heavy, heavier than that last one. Doesn't seem to be scratching glass. It's leaving, I didn't do a streak on the last one. It's leaving a metal gray metallic streak. This one won't even leave a streak. So it'll probably scratch the knife. Oh, it's not. Does the knife scratch it? Yeah, softer than the steel blade. I'm surprised, it's so heavy. Oh my word. I don't think it's even scratching the penny. Yeah, softer than a penny. So a penny is pretty low on the hardness scale. So this means it's less than 3. Will my fingernail scratch it? No. So we're looking at like 3. Oh, I'm curious about that one now. It's not magnetic. Some of the black metals are. I should do one more. This one has concoidal fracture. So when I shine it, it's on different planes. It's not all on the same plane. So it still has that shiny luster, but it's not all in one. It's like all over the place. Like I'm seeing them all going at different angles at different times. It's not one smooth plane. This is concoidal fracture. and harder than glass, which means it's 6 or more. I don't have any of the things that we can test harder than this, so we're just going to have to know it's 6 or more. So I'm going to give you a copy of this book as a Word file or a JPEG file. We have a non-metallic luster light color. That was our first. This does not look metallic and it's a light color. Now, was it harder than glass or softer than glass? Do you guys remember? So if it's softer than glass, we go down here. If it's harder than glass, we go up here. So if it's softer than glass, our next question is there prominent cleavage or absent cleavage? And then if it's harder than glass, we go up here and it's asking the same question, cleavage prominent or cleavage absent. And basically at this point, if you've got a light colored mineral, if it has prominent cleavage, it's one of the feldspars. And if it doesn't, it's one of the quartzes. So of our two minerals here, we've got two light colored minerals, one with concoidal fracture and one with cleavage. And then it tells you, if you read good cleavage in 2 directions, approximately 90 degrees, commonly light to dark pink, pearly vitreous, potassium feldspar. Good cleavage in 2 directions, approximately 90 degrees, white or gray, striations on some cleavage planes, plagioclase feldspar. So that's what this is. This is plagioclase feldspar. So this one, if we're looking, it has concoidal fraction, harder than 6, transparent to translucent, vitreous luster, which is this kind of silky kind of look to it, like not shiny but not see-through, like liquidy. Crystals terminated by 6 sides. So if we had a crystal, it would be a 6-sided crystal, but we don't have a crystal. And then it comes in tons of colors, one of them being rose pink. So we have quartz. This one that we were looking at has a metallic luster. So we're going to go over here. So there's a non-metallic luster dark color, and then metallic luster over here. And once we have metallic luster, it gives us 3 options: black, gray, green, black streak, brown or reddish brown streak, yellow brown streak. So our streak was a dark gray. So we're doing this first bit here. Perfect cubic cleavage, heavy. Hardness 2.5. So remember how a penny scratched it? Silver gray color, bright metallic luster. It is galena. And it has lead in it. That's why it's so heavy. So I'm hoping if you find any minerals, you will be able to use this chart to ID the minerals you find. I wanted to show you, here is a piece of pyrite. It looks gold, but it also has a gray streak. So golden yellow, you'd have chalcopyrite. Brassy yellow, cubic crystals, you'd have pyrite. So this one, because it doesn't seem to have, this is, I think this is actually, it's actually pyrite, not chalcopyrite. It's just not in crystal form. Because it doesn't look like gold and yellow, it looks like brassy. And that is it for our minerals. Good luck.